Welcome to methanol as a fuel panel in this second day that we're discussing fuel options for the future. Now, in this session, we'll be discussing about methanol in one of the most prominent, let's say, options for the future. Methanol is a strong option in the battle of alternative fuels. It is proven as clean, efficient, and safe fuel that offers immediate decarbonization benefits with substantial net greenhouse gas reduction. Full compliance with IMO 2020 and a pathway that leads to net carbon neutrality may be a key advantage of methanol as an option. Now, in this panel, as in all other panels in this day, we'll be discussing more or less the same agenda for its fuel, market momentum, success stories, key challenges, drivers and barriers of methanol as a marine fuel, CAPEX, OPEX, and fuel price considerations, and more or less the competitive strengths and weaknesses of methanol as a case against other fuel options. Now, in order to have this discussion, we have gathered a panel of experts. Let me introduce them to you. We have Greg Dolan, who is the CEO of Methanol Institute. We have Berit Hinnemann. Berit is a Senior Innovation Project Manager and Technical Innovation for AP Møller Mærsk. Stamatis, who is the Regional Bulk Carrier Segment Director for Maritime, Southeast Europe, Middle East, and Africa for DNV. Now it's the new name of DNV for those who are not familiar and stick with the DNV. Now it's DNV. Gary Noonan, who is the Head of Transition Technologies for Ardmore Shipping Services based in Ireland. And last but not least, Douglas Wright, who is the Regional Advisory Services Manager for Lloyd's Register. I would like to welcome you all into this panel. And I would like, as we have the first order of business, the introduction, let's say, out of the agenda, I would like to proceed and commence with a set of presentations, giving the floor to Greg. Greg, if you could be kind enough to share your screen and let us have the opening to the panel from the association perspective.
Well, thank you. It's a pleasure to be part of today's GREEN4SEA virtual forum. Let me add that it was also an honor for the Methanol Institute to be a nominee for this year's GREEN4SEA Clean Shipping Award. By way of introduction, the Methanol Institute serves as the trade association for the global methanol industry. We represent the world's leading methanol producers, distributors, ship operators, technology companies from our offices in Washington, Singapore, Brussels, Beijing, and Delhi. In these brief remarks, I'll discuss the role of methanol as a future-proof marine fuel. Globally, most methanol is made from the steam reformation of natural gas. Mature technology facilities have produced 5,000 metric tons of methanol per day. In China, they produce much of their methanol from coal gasification. Methanol also can be made from a wide range of renewable feedstocks. Now, methanol is an essential building block for hundreds of products that touch our daily lives: paints, plastics, building materials, car parts. Methanol is also an emerging energy resource used directly as a fuel for cars, trucks, ships, industrial boilers, and cook stoves, as well as a feedstock for other fuels like biodiesel and DME. In addition, methanol is an excellent hydrogen carrier for fuel cells. Last year, global methanol demand was nearly 100 million metric tons. Over the past decade, methanol demand has more than doubled, with growth led by two markets: methanol fuel use and the production of olefins from methanol. China is by far the world's largest consumer of methanol, responsible for more than half of global demand. Recently, the Methanol Institute released a joint report with the International Renewable Energy Agency, Innovation Outlook Renewable Methanol. This is the first comprehensive assessment of renewable methanol. These days, we all like to color code our fuels. For methanol production, at one end, we have coal-based methanol, which is pretty much exclusive to China and could be considered brown methanol. Conventional natural gas-based methanol is gray. Blue or low carbon methanol will be based on natural gas feedstock with the addition of renewable electricity or green hydrogen and possibly CO2 captured from a neighboring industrial facility to reduce a plant's overall carbon footprint. Green methanol also can be biomethanol produced from biomass gasification of municipal solid waste or forestry residue, or from biogas produced at landfills and wastewater plants. Green methanol also can be made from green hydrogen produced from renewable electricity through electrolysis, plus CO2 from industrial sources or direct air capture. This is also referred to as e-methanol. which is an electro fuel, an e-fuel, a synthetic fuel, a powered X fuel. There's also a hybrid route, which we presented in the report, where green hydrogen is joined with CO2 from biomass or biogas resources. Often these two green methanol pathways, biomethanol and e-methanol, are referred to broadly as renewable methanol. In this report, Readiness suggested that global methanol demand could increase fivefold over the next 3 decades to 500 million metric tons by 2050, with 115 million tons from conventional fossil feedstocks, 135 million tons from biomethanol, and 250 million metric tons as e-methanol. This report includes several tables identifying current green methanol production plants and announced projects, which I've totaled here. The challenge over the next decade will be to ramp up production of biomethanol and e-methanol to greater commercial volumes. Now, keep in mind, the methanol molecule, CH3OH, is the same whether produced from gray, blue, or green feedstocks, which will facilitate the transition of low carbon and net carbon neutral methanol as more ships use the fuel. Our joint report with Arena also provided intricate assessments of the cost of renewable methanol production today and where it's heading in the future. Last week, spot methanol pricing in the US Gulf Coast stood at $400 per metric ton, or the high end of the light gray bar across the bottom here. And I would note that fossil-based methanol can already be competitive with petroleum-based fuels on an energy content basis. Now, depending on the feedstock costs, some biogas and biomass processes are economically competitive today with conventional methanol, as shown in the green bars. Where we can expect to see dramatic cost reductions in line with expectations for more affordable green hydrogen is in the future production costs of e-methanol, pictured in the blue bars. The report finds that cost projections for renewable methanol by 2050 are within a range of current fossil methanol and petroleum-based fuels. Now, when we look at fuels for transport sector, energy density matters. While methanol has just half the energy content of diesel bunker fuels, it is liquid at ambient temperature and pressure with higher energy density than other alternatives like ammonia, hydrogen, and batteries. If we think about the global resources for solar and wind power, it's much easier and cheaper to turn these green electrons into methanol and move it around the world. Last year, the IMO approved the use of methanol as a fuel for ships with the adoption of interim guidelines for the use of methanol as a low flashpoint fuel, so the requirements to safely use methanol have been established. There are vessels on the water today using methanol dual fuel engines, including a dozen 50,000 deadweight ton chemical tankers. One of the world's largest RoPax ferries has been operating on methanol going on 6 years now. We've run a pilot boat in Sweden and dry bulk barge in China on methanol. There are also vessels using methanol as a hydrogen carrier for the hotel load or for propulsion. These ships have logged more than 100,000 hours of operation on methanol. MAN's two-stroke dual fuel engines using a unique injector system are available commercially today, with MAN already boasting 26 engines in their order books. Now, methanol offers solutions for both new builds and the retrofit of existing vessels, so ship operators can act now to adopt methanol. More methanol-fueled vessels are on the way, and we'll hear next from Mærsk, which recently announced that the world's first carbon-neutral liner will be operating on methanol dual-fuel engines by 2023. As you can see from these recent announcements, the vessels being built now include more chemical tankers, tugboats, workboats, yachts, and cruise ships operating on methanol. 3 of the Methanol Institute's leading member companies, Methanex, Promon, and OCI, have invested in methanol-fueled vessels, showing industry support from methanol producers. Methanol is one of the world's most widely shipped chemical commodities. Methanol storage is already available at more than 100 ports in the 100 of the world's largest ports. Last year, we worked with Lloyd's Register on developing bunker guidelines for methanol and also supported work by the EU SEN to develop bunker guidelines for methanol's use in Arctic shipping. These pictures here show the truck-to-ship bunkering of the Stena Germanica RoPax ferry in Gothenburg. Again, as a liquid fuel, methanol bunker systems are available and affordable. And finally, here's our global contact information for our team. Please check out our website at methanol.org and follow us on social media. Thank you.
Thank you very much, Greg. Now let's move to Stamatis. Stamatis, if you could share your screen, please.
So, good afternoon. Today I will present the results of a study we as DNV carried out, and in particular with regards to the position of methanol in the IMO decarbonization pathway. The choice of energy converter and onboard fuel storage is critical. It's one of the most critical aspects, decisions for a ship owner needs to take looking for a new building project. As you can see the table there, there are many candidates as primary energy sources for shipping decarbonization pathway. Considering the uncertainties around future decarbonization, we developed a simulation model to test different scenarios for fleet growth, fuel prices, and regulatory developments. In the next few slides, I will present you some of the results. Change slide, okay. First of all, we introduced the alternative fuel barrier dashboard to indicate the status and maturity of each alternative fuel. You may see the position of methanol with green color with respect to technical maturity. As you can see here, it is placed quite well. With regards to fuel availability, currently there is not much available, but as stated previously, we expect this to grow in the future. It is placed together with ammonia and hydrogen at this point of time. Infrastructure, again, we need more efforts to develop infrastructure for methanol. However, in terms of safety, it is currently placed quite very well. Regarding cost, capital cost, again, it is placed very well. The energy cost at this point of time seems to be quite expensive together with ammonia and hydrogen. However, it presents a very good volumetric energy density compared, for example, with ammonia, hydrogen, or batteries. So our greenhouse gas pathway model handles various kinds of input relating to the baseline fleet, seaboard trade, technology cost, as you can see here on the top, fuel prices, and regulatory developments, and produce as an output the future fleet. You can see here at the bottom, CO2 emissions, fuel mix, and cost. For our discussion today, we will concentrate on the fuel mix. So, next slide. Our model covers three decarbonization ambition levels. The first one is no ambition, with only the current design requirements from ship owners aspects. The IMO ambitions, which includes design and operational requirements, mainly the EXI and CII, and the future price on carbon, and a stricter decarbonization level by 2040, which includes stricter design and operational requirements and also a higher pricing on carbon. It includes, our model also covers two fleet growth scenarios, a low growth, you can see, and high growth scenario, and three different fuel price scenarios have been constructed. As you can see, a price scenario with low biomass price, a low electricity price, a low blue and fossil price. So in total, we have 30 different scenarios incorporated in our model. The results of our model indicated that there are no clear winners among the many different, let's say, fuel options. However, biomethanol appears frequently with a high market share in the decarbonization scenarios. As you can see here, the biomethanol appears in IMO ambition scenario with blue line, and also in the stricter decarbonization scenario with green line, 8 times. And as you can see, it gains almost 90% of the share of total energy used by shipping in 2050 in the 2040 decarbonization scenario, and almost 80% share of total energy used by shipping in 2050 in the IMO ambition scenarios. It is interesting to note that in the no ambition scenario, biomethanol, but also ammonia do not appear. You can see it here. So this figure shows the share of shipping energy users in 2050 for each model fuel type in each of the 30 scenarios described. You can see methanol with green color. There are large differences between the no ambition scenario that you can see here on the top and the decarbonization scenarios. Methanol, but also ammonia do not appear here in the no ambition scenario. However, in the IMO and the 2040 decarbonization scenario, where a favorable biomass cost is assumed, biomethanol plays a dominant role, and you can see here the green lines with the dominant role of biomethanol on these decarbonization scenarios where we have a favorable, a low biomass cost. In this example shows actually the scenario number 19, which is interesting for methanol side. Following the IMO ambitions, with a fuel price scenario favoring biomass and low seaborne trade growth that you can see here. In the example, you can see the most important fuel transitions for each decade. From 20 to 2030, here at the bottom, you can see the increasing use of LNG in new buildings and with blue color, and some retrofit to scrubbers that have already carried out. After 2030, we see a significant growth in methanol on new buildings. Regulations start to have an effect with some retrofits from LNG to methanol. And you can also observe by shade of the yellow and blue color here, the yellow and the blue color here, the drop-in fuels like bio-NGO with the yellow and bio-LNG applied in the existing vessel. From 2040 and onwards, new builds built to run on methanol. This underlines the importance of choosing fuel flexibility solutions and technology on board vessel as a way of future-proof ships. And going to the last slides, in order to summarize, over the next decade, the shipping industry needs to start rolling out a new generation of carbon neutral ships. To drive the development of new fuels and technology, we need a clear and robust regulatory framework to be in place. It is hard to identify clear winners among the many different fuel options across all scenarios, but we believe that biomethanol, together with e-ammonia and blue ammonia, are the most promising carbon neutral fuels in the long run. And we see also that LNG gains a significant share until regulation tighten in 2030. We also see some bio-LNG, LNG as drop-in fuels in the existing ships. And this completes my presentation. Thank you very much.
Thank you very much, Stamatis. Now let's move to Berit. Berit, if you can share your screen and let us have your presentation, please.
Yes, thank you very much for inviting me to this GREEN4SEA virtual forum on methanol as a fuel. Yeah, I'm Berit Hinnemann from Mærsk, working with decarbonization, innovation, and business development. And what I would like to talk about is our journey towards decarbonization and how we see the fuels of the future. To start with, I don't think I need to introduce Mærsk much. We are an end-to-end logistics provider, enable our customers to trade by transporting goods anywhere. We are more than 80,000 employees present in 130 countries. And I would like to draw your attention to a couple of numbers which are important in the context of the decarbonization challenge that we have to solve. Is that we have a fleet of more than 700 container vessels. Our fuel oil consumption each year is about 10 million tons per year. That also gives a dimension of the decarbonization challenge, and also our scope 1 emissions, which primarily arise from our container ships, are about 33.9 million tons of CO2 equivalents per year. And with decarbonization, we have announced a bit more than 2 years ago that we want to have a carbon neutral operation in 2050. And we see this as a strategic imperative. We need to decarbonize in order to stay relevant to our customers, and in order to decarbonize their supply chains, and in order to reduce our CO2 emissions. We have always placed a big focus on energy efficiency improvements, as you can also see on this graph. And compared to 2008, we have achieved relative energy improvements of 46% reduction per container transported. We will continue this work and targeting a 60% reduction. But in order to go to carbon neutral operations, we need to transition to different fuels. And this is what I will talk about in the remainder of my presentation. If we now take the bird's eye view, if we need to make the transition from fossil feedstocks to renewables. And in terms of feedstock, that can either be biomass, renewable electricity, or a combination of both. And since our announcement of the of our goal to be carbon neutral in 2050, we have done a lot of work and analysis to see what fuels are feasible for container shipping. And what this has resulted in is that we are following 4 pathways. We are pursuing biodiesel and also advanced biofuels. And we are already using biodiesel today in our fleet and are selling carbon neutral container shipping via our eco delivery product. We are also pursuing methanol, where we are especially looking at green biomethanol and e-methanol. We are also pursuing lignin fuels and ammonia, especially green ammonia. And on the next page, what I would like to do is briefly go through these pathways that we are pursuing, pointing out their key advantages and also some limitations and risks. For biodiesel, the key advantage is obvious. It can be used as a drop-in fuel in existing vessels and engines, and we and others are already doing that today. As for key limitations and risks, what we see is there is a limited availability of biomass feedstock, so we do not see it as realistic to decarbonize our entire fleet on biodiesel alone. This is why we need to pursue other options as well. And also we see a price pressure due to competing demand from other industries, such as the aviation industry. And we also foresee that this will increase in the future. As for methanol, as already the previous speakers of this session have pointed out, methanol is already in operation as a marine fuel, and also a methanol engine is available. So from the technical point, it is a feasible solution today. And it is also a liquid at normal conditions, and the handling is well known from the methanol industry. So, so in terms of implementation, it is feasible. As for limitations and risks, for both biomethanol and e-methanol, you need biogenic carbon, which in the case for biomethanol comes from biomass feedstock, and in the case for e-methanol comes from a biogenic CO2 source or down the line from direct air capture. And that can pose a limitation in terms of development for green methanol production, but we do see a lot of opportunities in this space. With lignin fuels, we think that lignin fuel blends, that they are interesting. Lignin alcohol blends are interesting because they can be potentially the most price competitive net zero fuels, possibly almost on par with fossil fuels. And also the energy density, by blending lignin in the alcohol, you can also increase the energy density. And also we foresee similar engine requirements as for methanol. However, they are still in development stage. Production needs to be scaled up, and also additional engine tests need to be done. So they are not feasible at scale today. We also pursue ammonia. And if it is produced as, for instance, green ammonia with no upstream CO2 emissions, it is a fully zero emissions fuel. And it has the advantage that it can be produced at scale from renewable electricity alone. So from a feedstock and production perspective, it is very attractive. However, there are safety and toxicity challenges. An engine is under development and has been announced by MAN to be available from 2024 onwards. We also see infrastructure challenges at ports. So, so there, from a feasibility standpoint, some more work needs to be done before this is a technical feasible solution. So, but for methanol, this is a solution today, as it is mentioned, and this is also why we have recently announced that we are taking specific steps now. In particular, we have announced that we will operate the first carbon neutral liner vessel by 2023, which is 7 years ahead of schedule. Originally, we had announced this for 2030, but as we have realized, this is already technically feasible today, and this is a way to take some specific action and make some immediate impact. So this vessel will go into operation in 2023, and also all future Mærsk-owned new buildings will have dual fuel technology installed for either carbon neutral operations or operations on very low sulfur fuel oil. Here on the last slide, I show some details about this carbon neutral container vessels. Capacity will be 2,000 TEU. It will have a dual fuel engine for operation on methanol and very low sulfur fuel oil, and will trade in one of our intra-regional networks. And we plan to operate the vessel on carbon neutral e-methanol or sustainable biomethanol from day one, with production of this green methanol as the key challenge. But our hope is that this can kickstart the rapid scaling of green methanol, and collaboration across the value chain will be a key to make this happen. So with this, thank you very much, and looking forward to the remainder of the panel and also to the discussion.
Thank you very much, Berit. Let's hear from Gary now to complete this round of presentations. Gary, if you can share your screen.
Okay, first of all, thank you, Kostas, for having me here today. Pleasure to be asked to this on behalf of Ardmore. My name is Gary Noonan, and I'm the Head of Energy Transition Technologies for Ardmore. As the other panelists covered a great deal of the benefits of methanol as a marine fuel, I'd like to discuss how Ardmore concluded that methanol was the future fuel of choice for us. As we all know, the global energy transition is accelerating, and the maritime industry is under increasing pressure to keep pace through regulatory changes and progress towards emissions reductions and eventually zero carbon vessels. In response, Ardmore developed our own approach with our energy transition plan to focus on the right opportunities proactively. The energy transition plan builds on Ardmore's existing strategy and strengths. Through our research, it has become clear that a lot of emphasis has been on main engine decarbonisation, and we felt that there was a specific need to concentrate on auxiliary engines. We therefore set ourselves the goal of effectively decarbonising one of our generators, which we are affectionately referring to internally as our generator challenge. Looking at the various technologies available to achieve our generator challenge, the one technology that kept emerging as a logical choice for us to achieve low to no carbon emissions was PEM fuel cells. However, once we dug a bit deeper, it became clear that the biggest obstacle to making a fuel cell a near-term reality and an attractive choice was the safe and efficient supply of ISO-grade hydrogen on board. Compressed hydrogen was not a viable answer for deep-sea vessels, as the volume, weight, and cost of the storage infrastructure proved to make the solution viable. This led us to find a solution that could reduce the delivered cost of hydrogen on board at the fuel cell, while also reducing the volume and weight requirement for the fuel. The solution we found was a methanol to hydrogen generator. Through a research process, we identified a company, Element 1 in the US, whose technology, or whose methanol to hydrogen generator as a solution to our hydrogen transport issues. In fact, we were so impressed with what we saw that we entered a joint venture with Element 1 and a third-party Maritime Partners, which is a US-based finance provider, to bring this technology to the maritime market. The solution occupies less relative space to compressed hydrogen than a compressed hydrogen solution, with 1/3 of the hydrogen being derived from the water mixed with the methanol fuel. This results in a greater operational range from the hydrogen fuel cell solution. It offers attractive CAPEX and a significantly reduced OPEX when compared to a Tier 3 engine. Moreover, this removes the potential for maintenance-induced generator failures and insurance claims that unfortunately are all too common across the industry. It helps solve the high cost of hydrogen storage and the high cost per kg of hydrogen at the point of use. It has 0 SOx, 0 NOx, and 0 particulate matter, and a reduction of approximately 20 to 30% in CO2 emissions when compared to a standard auxiliary diesel engine when used with grey methanol today. If used in conjunction with green methanol, the onboard carbon capture systems currently being developed, it has the potential to be carbon negative fuel. This could be a massive positive for methanol over the alternatives in the future fuel race. The system requires minimal maintenance with simple routine servicing every 12 months, with the major servicing aligning with the vessel's survey schedule. The system is scalable, with the modules being stackable to meet various installation requirements. And as we've heard from previous panelists, methanol can be transported and stored similar to the liquid fuels we use today to enable the supply chain to switch to methanol without the costly infrastructure needed for other solutions, thus making it, in our minds, the leading fuel for the energy transition. And that's it. Thank you.
Thank you very much, Gary. Now, in lieu of a presentation, let's hear from Douglas his thoughts as an opening statement, let's say, to what we are about to discuss. Douglas, can we hear your thoughts?
Thank you, Apostolos. Yeah, the presentation that the other participants have presented really clearly articulate the attractiveness of methanol as a fuel. I think from an observation point of view, the fact that methanol can be produced through various pathways and go from grey to blue to green, etc., is an attractive way forward, because we can start now and not have to necessarily wait for the other alternative fuels to become a realistic option. From a classification society perspective, and certainly having worked with the Methanol Institute personally, I like the fact that methanol is liquid, and we did some work on bunkering procedures for methanol, and it's very clear to me as a bunkering specialist myself that handling methanol is not really that much different from handling gas oil. Okay, you need to be a little bit aware of the toxicity of it, but that can be easily overcome with fairly minimum modifications to fuel transfer systems and fuel management systems on board ships. I also think the attractiveness of methanol as a fuel by using the existing gas oil infrastructure is an easy or relatively easy conversion into methanol. So there's a lot to like in methanol, Apostolos.
Thank you very much, Douglas. Now, I would like to start our discussion, and I would like to go back to Greg and clarify a number of things. I've seen your presentation about, I'll start with the fuel price. I've seen your presentation comparisons, more or less, in terms of how many times was, let's say, or maybe the price of the methanol compared to the existing fuel oil. Can you give us some rough figures? Because I've seen something in the range of 2.5 times or something like that, but I want you to clarify that.
Yeah, I mean, if you look at methanol, it does have about half the energy content of standard diesel bunker fuel. So you'll need roughly twice as much, or 2.25 more methanol. But even when you look at methanol on an energy content basis and pricing compared with heavy fuel oil, marine gas oil, there are certainly times when methanol has been competitive already, and that's fossil-based methanol. So, you know, we do see the opportunity for methanol to be price competitive. I think when you look at the overall total cost of ownership for a ship operator using methanol, the CAPEX will be lower. Certainly the operating costs will be lower than some of the other alternative fuels that are being looked at today. So, you know, methanol can be a very attractive option for shipping, and, you know, the shipping operates on a bottom line. So, you know, cost does matter, certainly fuel costs, but, you know, again, you really do need to look at total cost of ownership. And methanol as a liquid at ambient pressure and temperature will be a much easier fuel to move around and to build the infrastructure, as Douglas is just pointing out. Yeah.
And how about the price volatility and the supply to the market? Should we be worried about that?
Yeah, you know, I think when you look at methanol pricing over time, historically, we've followed pretty closely to the price of oil. About 40% of the methanol market today is tied to some energy application. So that's going to have an impact on methanol pricing. I think what we've seen more recently over even like the last 10 years, that the lows and the highs of methanol pricing are flattening. So we don't see the kind of steep spikes that we've seen in the past. And, you know, part of that too is just the growth of the market. Again, if you look at global methanol demand, we more than doubled demand in just the last 10 years. And now, you know, markets like the market for olefins in China represent 25% of global demand. And it's also an indication that methanol production can rise to meet a single demand. Again, with methanol to olefins, that market didn't exist in 2010, and now it represents 25% of global methanol demand. So the production is caught up to that kind of single demand, which could be the case for shipping as well.
Okay, thank you. I would also like to have some sort of feedback from the owner perspective. If Gary may comment on the CAPEX and the OPEX compared to other options of fuels.
Hey, so yeah, when we were doing our modeling, you know, looking at methanol as a fuel, we wanted to have something that we could use today, not a solution for 10, 15 years down the line. So we actually modeled it against the Tier 3 diesel engine running on gas oil. And, when you look at the efficiencies across the plant, across the fuel cell and the hydrogen reformer, you actually come out a lot more efficient than a diesel generator is right now. And, if you were to use an internal combustion engine on methanol, the goal would be to get back to there. So we found that was a good base case to run it against. The CAPEX upfront is slightly more expensive than a Tier 3 engine generator. However, the OPEX over time, we have in our base case, we're looking at a return on investment of about 2 years, just due to the reduced OPEX. And, it comes back to, especially in the generator side of things, we see many failures, maintenance-induced failures. And, if you talk to anyone that's in insurance, they'll tell you that's their top liability. Even for them, I mean, you're talking 300 or 400K a time for that. So, taking that into account and taking the actual minimum maintenance for the fuel cell and the hydrogen reformer, it actually works out as very positive compared to an internal combustion engine even today.
Thank you. Berit, any thoughts? You have done a wider, let's say, review of how you would like to proceed forward. Any thoughts on the CAPEX and the OPEX of, let's say, how attractive is the solution of methanol compared to other solutions?
Yes. As for the CAPEX, we also find in line what has already been mentioned that the CAPEX, yes, there is an add-on CAPEX with new build, but we find that to be very manageable, and also for retrofits, it is manageable. So also in contrast to other fuels, retrofits on methanol are manageable. As for the OPEX, to be very clear, as also Greg has shown in his presentation and has been mentioned, there will be a premium cost for green methanol. That is very clear. And also, we also depend on our customers to value this sustainable transportation product. And we also have reason to believe that some of our customers do that. First of all, I'd also like to mention one fact, that if you look at how does additional fuel costs translate to shipping rates and then translate to cost increases for the end product, we have done that calculation for a couple of consumer products. And we find, for example, for a pair of running shoes that are transported from Asia to Europe, that the end customer would have to pay 6 cents more for those running shoes, roughly, in order to have them transported carbon neutral. And we have reason to believe that at least some customers will do that.
Yeah. Okay. Now let's move to Stamatis. Stamatis, in your presentation, you presented, we've seen similar presentations in the past, a number of pathways as you presented and now outlined towards decarbonization in 2050. And I'm one of those who believe that in many cases, due to the lack of a clear regulatory framework, we are talking about too many scenarios and people are being confused. I would like to ask you from the class perspective, and I would also like to go to Douglas as well on this, what sort of, let's say, assurances, regulatory-wise, what sort of steps should we take as an industry to make this discussion a much more, let's say, certain discussion, because there's a lot of uncertainty now. And as I said, you have to, a number of scenarios, and you cannot, and we cannot, as an industry, we cannot be sure which scenario will prevail, because changing the regulatory parameters, that would change the whole picture. From your point of view, what would you like to see regulatory-wise in the near future?
Yes, this very valid point that you raised, Apostole, and this is the main concern for many ship owners these days, because there are ship owners looking for new buildings. They would like a future-proof ship, a future-proof design, but actually they do not know what is coming down the road. And this is something that IMO has to play an important role. We're expecting, of course, developments in the next MEPC meeting to close the short-term measures. And we see also some papers opening the discussion for the market-based measures that have been submitted and expecting these midterm measures to be adopted within, the mid of this decade, 25, 26, etc. And also there is another, let's say, parameter, which is the European Commission, that we expect also some measures. So we need a clear regulatory framework in order owners to be able, and we as class societies, to support them to take some firm decisions about the best solution.
Sorry,
yes.
Yeah. Stamatis, yes.
And yes, that is important, IMO to progress. Of course, there was a delay due to the COVID restrictions, and all these meetings have been carried out now remotely, but we hope that there will be some decisions at the next meetings.
Okay, I'll come back to the EU issue. We have a question about it. Let's hear from Douglas. Douglas, what's your take on what we're seeing with the regulatory framework?
Yeah, I really feel very much, sympathy and concurrence with the previous speaker's assessment. But I think the biggest unknown is the concept of life cycle emissions. It's all good and well to look at shipping in isolation and look at tank to funnel emissions, but actually shipping is part of a rather larger value chain. And I think the production of lower carbon or zero carbon fuels should also be taken into account. So, for example, if we look at the likes of LNG and methanol, yes, we know there's a reduced carbon benefit now, but if we extrapolate it and look at the production of LNG and the production of methanol, how does that impact the overall life cycle emissions? Because ultimately, it's no good if shipping reduces its emissions and the upstream emissions increase. Then we're not really contributing to the larger question of sustainability and making sure that the world will be a better place for the future generations. So I think life cycle emissions is really clearly a challenge that we need to get to grips with rather soon, I would suggest.
Okay. Now, I would like to, let's say, start a round of questions now addressed to all of you. I think one of the conclusions that we have made, I think it was also clear to the market for the, I think from Berit presentation, was that there's no sole, let's say, fuel that will prevail, or we don't know for the time being what would be, let's say, the dominant fuel in 2050. And I understand that the whole industry has to move toward, and I think Berit again correctly pointed out that we have to seek a number of alternative ways of how to do that. Now, the best alternative option, the first step to decarbonization, there's a consensus for this in the market, is LNG for the time being. So that's the first step. We don't know if LNG will be there in 2050, but we know that now it's the first step. I would like to ask you and hear from you what lessons may be learned for methanol and for other fuels as well, out of the LNG, let's say, developments. Are there any lessons to be learned and applied, of course, to methanol as a fuel, adoption to the market? Let's start from Greg.
Yeah, I think there were definitely some lessons that were learned. If you'll just look at the IMO adoption of methanol interim guidelines as a low flashpoint fuel, LNG went first. And a lot of the requirements for methanol were based on LNG. Of course, we also have to understand just what the physical properties of methanol are and what its risks are and mitigate those risks, which are quite different from those of LNG. So I do think we learned from the LNG example, particularly at the IMO standard level. And I think if I can, just going back to the last discussion, Douglas mentioned life cycle emissions. And I think that's one of the big debates in shipping right now is whether we look at emissions from a tank to wake or a well to wake basis. I think we've seen even the European Commission and DG Move recently signal that they would prefer a well to wake basis and bring in the full fuel chain and make the whole the chain responsible for meeting the goals of becoming carbon neutral with shipping.
I think it's obvious that we're talking about well to wake. I think it's tank to wake. What you said maybe it was 5 years ago or something like that, but now the industry has moved past that point. I'm sure there are several lessons to be learned from the LNG history so far. Stamatis, your thoughts?
Yes, Apostle. Definitely there are lessons to be learned. The good thing is that with LNG and the use of LNG with the industry, we as industry would develop the IGF code. And this, of course, provides, let's say, an international standard for ships using flash low points fuels. And also, as you know, this standard has been incorporated also in our classification society's rules. And so we are, let's say, better prepared in terms to address the safety aspects of the new fuels that are coming down the road. So I think this progress with LNG has helped, and let's say somehow it's opened the door for other fuels to be adopted by the shipping industry. One point on the very good, let's say, comment raised by Douglas and Greg about the life cycle greenhouse gas emissions is that the way I see now, IMO is trying to address this issue, the well to wake or tank to wake. It seems, and looking at the draft guidelines, life cycle guidelines prepared by Australia and others, Japan, is that I think that IMO does not want to be accountable and responsible for the well to wake emissions. They believe that IMO and shipping should be accountable and get the burden for the tank to wake emissions. The part from well to tank, it should be, let's say, allocated to the nations, and the nations that they produce and transport the fuel should be responsible for the emissions on that part. However, in the guidelines, they have a clever approach with a labeling system where a ship owner will have an information about, through this labeling system, about the fuel from the well to tank. So an owner can take a better informed decision about the fuel that he's going to use.
Thank you for highlighting that, because someone might say it's a short-sighted approach, but again, it's a practical approach because someone has to, get some practical turnarounds around this, and it's an interesting approach of what they are applying in the IMO. Douglas, your take on this? Any lessons from the LNG developments?
Yeah, I would say that I concur with Stamatis' excellent summary here. I think just to remind the audience that if we look at the emergence of LNG as a fuel, that was very much driven by low sulfur regulations and not necessarily the topic that we discuss now. And in my mind, LNG had a good press bureau behind it because it did have proper marketing behind it as a low sulfur fuel. And to an extent, methanol lost that battle at the time. And I think that was very much driven by the actual supply locations and the image of LNG as a low sulfur fuel. And I think now we're in this area where we're now talking about decarbonization, and to an extent that has leveled the playing field for alternative fuels, so that we're not only talking about LNG as a short-term measure, but it allowed methanol to slowly but surely muscle itself in as a very viable pretender to the throne, at least short-term and possibly medium to long-term as well.
I have to also add to what you say. the point of which one fuel will prevail, it's a marathon, it's not a sprint. I agree.
Correct.
I fully understand why you say that LNG had a better press office and gained more visibility at the beginning, but it's a marathon. And we see that the market is shifting its attention now as we move towards 2030, maybe 2050. And again, I'll put the Green Deal and the EU decisions in our next round of questions. Let's hear from Berit. Berit, what's your take? What we have learned so far from what's happening with the other fuels, and how you incorporate this into your decision making as you progress towards the 2050 goals?
Yes, thank you. And I would like to add a couple of our viewpoints to the discussion. I'd like to second some of the previous speakers that life cycle analysis from a well-to-wake perspective, covering the entire life cycle of the fuel, is crucial for this. And also it needs to include all greenhouse gases, not only CO2, but all greenhouse gases such as methane, laughing gas, and everything that is relevant to the analysis. So this we see absolutely crucial as a decision factor for which fuels to go for. And the second point that I would like to add to the discussion is that our view is that there is no time for transition fuels. And this is why we go to the green methanol straight away, because we need to make an impact in this decade, and we have a very urgent problem to solve. And we have the technical means to do so with a ship driven by green methanol, and therefore this is why we are going for, to also account for the urgency factor. So these are two aspects that we think are very important to the discussion. So we also see we need to take some specific actions now. Of course, take a view as to which solutions will become feasible in the future, and take a view to that something that is not feasible today may become so. But at the same time, we have solutions out there that work and allow for greenhouse gas emission reductions, to put those into operation.
Yeah. Gary, your take of how you approach the issue?
Hi, bosses, thanks. I fully agree. I don't think there is one future fuel. I think it's going to be dependent on your trade. And if I can say what we've learned from the LNG uptake, and I don't think the LNG uptake has been as great as people maybe publicize, you know, it's still quite a niche market. And that's mainly because the infrastructure to supply LNG is quite a costly infrastructure. And that's why if we look at it from Ardmore's point of view, we operate MR tankers on the spot market. You know, LNG is not an option for us unless we have LNG bunker terminals pretty much worldwide. Hence the reason that we specifically think that methanol is a better option for us, simply due to the fact that it's almost able to be used in the supply chain that we have right now, you know, with a small few updates, as opposed to completely rolling out a cryogenic infrastructure for LNG.
Okay, thank you. Now, I would like to, let's say, have a next round of discussion about the Green Deal. We have EU most probably enforcing an MBM, something like a carbon tax. We don't know the exact details in the near future, 2023, but we don't know the exact details so far. EU is talking about zero emissions imports in dock, maybe cold ironing, maybe 2030. They're talking about carbon neutral continent in 2050, much or less aligned with what Mærsk is saying, carbon neutral by 2050. I would like to ask you, what sort of incentives should we expect to see in the market? We know how the IMO process is working. It takes some time. COVID has slowed the process a little bit down. I'm sure that COVID won't be here in, let's say, in 10 years' time. We will resume the progress and the pace. Now, we know how fast or how slow IMO is working. We've seen the EU coming forward. What sort of other incentives? We have the Poseidon principles. We've seen that the financial institutions and the financial industry is saying, yes, we have to provide some finance, but we need to make sure that this is on a sustainable basis. So I'm asking you, and I would like to hear from you, what are the sort of incentives you expect to see in the market so that, let's say, make methanol a more attractive, let's say, option? Greg, your thoughts? Yeah.
Yeah, I think there's a lot of things that are happening in the EU right now, and some of them are more practical. So there's about to be an effort started with the EU to develop standards for bunkering connections for methanol for inland waterways. Because when we think about shipping, it's, 20% of the ships use 80% of the fuel, but there's a lot of marine ships. There's a lot of work boats, pilot boats, tugboats, and those are actually ideally suited for methanol. So when we look at the EU, part of the work is standardizing the bunkering, looking at the bunkering solutions. We also have ports now like Antwerp and Rotterdam that are going to be demonstrating methanol fueled tugboats and pilot boats. So let's get the vessels on the water with the ports. And then we also have ports in Europe that are looking at investing in renewable methanol production at the port facilities, including looking at the gasification of municipal solid waste to produce methanol at the port of Antwerp. So, some of those activities I think are going to be key to develop more of an understanding and experience around methanol use at the ports themselves.
Okay, Stamatis, your thoughts?
Yes, I agree with Greg. What we have seen from European Union side is that when the Parliament approved the revised text on the MRV, they introduced their plan for the emission trading scheme to be applied. And also they talked about this ocean fund, gathering 50% of the EU ETS will go into this fund, and they have plans to invest this on green fuels and building infrastructure in Europe towards decarbonization maritime shipping. So we understand that there will be some incentives coming from European Union. We have seen also in the amendments from IMO, the Marble amendments that have been adopted. It is the first step where into the Marble text they say that ships that will be rating as A and B should receive some incentives through the flag states, and there are already some announcements, maybe we have seen from Cyprus, saying that we are going to reduce the taxation for vessels that will be found A and B, and I'm sure that other flag administrations will follow on this. And I'm sure that there will be, as you mentioned, Apostol, other drivers. I'm sure ship owner side, Gary and Berit, who will have more to say on this about, I don't know, charterers and other incentives from market towards the decarbonization.
Yeah, I fully agree, and I would like to thank you for the excellent outline. I'm sure that the industry is looking for market pioneers like the one we're having in this panel. Mærsk and Ardmore are pioneers. Those are the pioneers who invest in new technologies. We also had Exmar in the LPG panel. So we're talking about pioneers. The market is looking for pioneers and is looking for success stories as well. And the market, I think, is eager to hear from those who are, experiencing these new technologies. And I'm sure that the market will respond. I'm sure about that. Douglas, your takes. What sort of incentives should we expect to see in the market?
Thanks for that, Apostolos. I really like Berit and Stamatis' answers just earlier now. I don't really want a crystal ball glaze and surmise which emission trading scheme or tax on bunker fuel would be the right approach. But I think if we look at the adoption of alternative fuels, it's very much about the pioneers, as you just suggested, Apostolos, and maybe the trailers in the industry. So whatever mechanism we adopt, we must realize that the pioneers are increasing the cost of operation of their ships, and they should somehow not lose out competitively against people who decide to trail in this story. So the market-based measures should level out the pioneers who have extra cost and not give an advantage to people who decide, let's sit on the back seat and see how this will evolve. So in my mind, that's a really important aspect of market-based measures to consider, so that whoever does or makes the decision, ultimately the net competitive position does not change. So I think that is a very important consideration. I think a final consideration, and this is more related to what fuel to choose, I think is very much linked to infrastructure readiness. Where is the investment going to be to make sure that these fuels are readily available? And I think that is the big question mark. For maritime industry, anything is possible, really. All technology is there. You can choose any fuel you want, but is it available? And I think that is the key point that needs to be considered by ship operators. And to an extent, the infrastructure investment needs to go in tandem with the maritime sector's desire to choose any particular fuel of choice.
Thank you, Douglas. I think Gary, in his previous comment, pretty more, I mean, nailed about the availability of the fuel, as you said, because he said if we don't have the fuel, we cannot compete in the market. So well, we understand that. Berit, your takes.
Yeah, and I would like to add to a couple of points that especially the previous speakers, but especially Douglas have pointed out, because also you have actually mentioned it, the pioneers, the first movers. It is very important to acknowledge and reward first mover efforts. Also a level playing field. I mean, to ensure by whatever the measures will be, to ensure a level playing field, and also to, in one way or another, close the competitiveness gap, because as we discussed previously, these green fuels, carbon neutral fuels, they will come at a higher price for some time to come, and this needs to be addressed in one way or the other. So so those are some of the key aspects that we think are very important to address in order to speed up this transition, because we don't think there's much time to do it.
Yeah, absolutely. Gary, your takes?
Yeah, just to echo everyone's comments, really. I mean, shipping is an extremely competitive business, and we've seen it with the 2020 sulfur cap. There's a race to be second. No one wants to be the pioneer, and there's a good reason for that. Early adopters generally get penalized. Let's look at the ballast water treatment legislation. How many people have had to modify their ballast water treatment systems after being, let's say, a good boy and getting it installed early? So there needs to be something, and I think, we're going to come back to the carrot and the stick, which is what everyone's talking about. We can either give financial incentives to do it early, or we can give legislative incentives to do it at a specific point in time. And to be honest, I think without the legislation, you're not going to get mass adoption, because some people just won't do it, and it's good to work for a company that's willing to spend money on trialing new technologies. And I'd love to stand here and tell you that all my ideas and all our wins work, but they don't, and that's just the fact of the matter. So, there's a lot of companies not willing to do that. And until, as Berit said, it's a level playing field, then I think we're still going to have this situation where there's going to be a few early adopters, and the mass will just wait back and see.
Yeah, fully agree. And the point that Douglas initially made about black and white, there's a lot of gray, and I fully agree that the pioneers should be benefited in some way. I mean, by the market. I'm not sure how, but it's a valid point, and I'm sure that most of our viewers are sharing this concern. Now, as we have to wrap up the panel, I would like to, let's say, sum up your thoughts. I would like maybe to ask you to take your crystal ball. I would like to ask you a couple of things, maybe one of the things. Now, I would like to ask you, what would you like to see to move towards, let's say, accepting methanol as a fuel? Or if you would like, you may ask a more general question and have your thoughts on this. How we should move into a more sustainable future towards decarbonizing the industry. Sorry. Greg, your takes. To sum up,
I think one of the comments that was made is we have to look at growing the fuel supply to meet the demand of the marine industry. And I know Berit and Gary are talking to our members, the methanol producers and the companies that are looking at making biomethanol and e-methanol. So, and again, it's those early adopters like Mærsk and like Ardmore that are having those discussions right now, creating those relationships, looking at creating supply chains and understanding how methanol works. And the point that Berit keeps raising too, I think is spot on, that we need to act now. We can't wait another decade or more for some of these other fuels to catch up. Methanol is a high technology readiness level today. There are commercial engines available today. You know, we're also developing more vessels that can operate on smaller ships, pilot boats, ferries, work boats. There's a program that's EU funded, fastwater.eu, that's looking at developing these kinds of technologies for short sea shipping. So we have to look at this from a holistic basis and begin starting to make those relationships today.
Okay, thank you. Stamatis, your take?
Yes, I think we need to have a clear and robust regulatory framework. This needs to be in place just to know what is coming and how we should, let's say, cope with this regulatory framework. As Greg said, we need to have develop our infrastructure and to meet the demand in these new fuels that shipping industry will have in the next decades. And very important is level playing field, clear rules, and also incentives for the early movers.
Thank you. Douglas?
Yeah, just to add to what Stamatis was just saying, I think if we look at it holistically, what is the challenge for zero carbon fuels? It's really the interplay between technology readiness, investment readiness, and community readiness. I would suggest for all of the alternative fuels, the technology readiness is kind of already there. So what is the big unknown? And that is the infrastructure investment readiness. When are these fuels going to be available? I think shipping has already given a clear signal that they can move, but what they need is a clear signal from the land-based infrastructure supply chain. Where can I buy it? At what price most likely can I buy it? And what is the mode of delivery available to me? And I think, and to remind the viewers as well, each fuel does have a different energy content. So the design of ships is important. Do I do more frequent bunkerings than I did in the past? Or am I going to build bigger bunker tanks? It's a very challenging discussion, but ultimately infrastructure readiness is important.
Yeah, okay. Berit, your thoughts?
Yes, thank you. I would like to also end with a couple of thoughts that 2 years ago, more than 2 years ago, when we announced our carbon neutral goal for 2050, we thought that was a bit of a moonshot. Today, we think it is possible. The solutions are there. So we need to start implementing them. And I would like to point out also, echoing previous speakers, the importance of collaboration across the value chain. We can start implementing today, and it needs to be done with very good collaboration across the value chain to realize these solutions. Thank you.
Thank you, Berit, for pointing this out, because collaboration is an issue we haven't even mentioned in this panel, but we've seen that collaboration is improving over the last, let's say, 5 to 10 years. If we go back 10 years and you see where we were 5 years ago and where we are now, correctly pointed out. Thank you for this. The collaboration is getting better and better. Gary, your takes in order to conclude the panel.
Yeah, I mean, there's many pertinent comments just came from the panel. You know, I think they've all nailed it, you know, specifically Douglas when he's talking about the infrastructure. One thing I would add is I think we just need to get these systems on the water, get the technologies matured, engineer out the issues, you know, till we have robust systems on board, you know, we're not going to see mass adoption.
Yeah, thank you all very much. Thank you for this extremely informative discussion. I'm sure our viewers will have more or less the same take. towards what we discussed here. I would like to thank you for taking the time to be with us. Thank our viewers, and looking forward seeing you in one of our future events. Thank you very much.
Thank you.